Hey friends, welcome back to the channel. Today we're going to be taking a look at LeetCode problem number 238, product of array except self. Let's not waste any time and let's go ahead and jump straight into the problem statement here. So, given an integer array nums, return an array answer such that answer index I is equal to the product of all the elements of nums except nums index I. Okay, and we got some other things here. The product of any prefix or suffix is guaranteed to fit in a 32-bit integer, and we want to write an algorithm that can run in O of n time and without using the division operation. And we see down there at the follow-up, and we're actually going to challenge ourselves and try to write something that's using O of 1 extra space complexity. So let's break this problem down. What exactly is it asking us to do? Well, if we have an integer array here of nums like it says we have in the problem statement, 1, 2, 3, and 4, we know that we want to be able to generate output that will be 24, 12, 8, and 6. Now, ordinarily, if we wanted to solve this using the division operation, how would we go about doing that? Well, one thing we could do is we could have a product here that will just simply go through the original array and it'll multiply all the values together. So 1 times 2 times 3 times 4, which in this case is going to give us a total value of 24. Then what we could do if we want to generate our output array here, we'd be able to just take 24, the product of all the values in the array, and then we'd just be able to divide by each value that was in the array at that position, and then just go ahead and generate our output for us. The challenge here is that we're not allowed to use the division operator, so how can we get around that? So one thing that I want to point out here is that generally speaking, we'd be able to generate this output array in a 3-step process. Now what exactly do I mean by that? Well, let's think about what it means to generate the output array that we're generating. If we have an array of arbitrary length here, so we have some number of values inside of the array, and then we have n minus 1, n plus 1, and then it just continues on for however long. If we wanted to find the product of the array using any value inside of this, we could break it up such that we have a pointer here pointing at our value at n. We have a bucket of all the values on the left-hand side of that, and we have a bucket of all the values on the right-hand side of that. Now, if we wanted to generate the product of the entire array, we'd be able to take our group here at our position 1, we'd be able to multiply that by n at the middle there, and then we'd be able to multiply that by our group here, and then that would give us our product. So with that being said, the next important thing to realize is that, well, we could just take this n value here, and we could just get rid of it. And so why that's important is because it'll give us the product of all the values to the left of the value at index n times the product of all the values to the right at index n. And that is exactly what we're looking to be able to put in our output array at some index m. So then the question becomes, well, if that's what we can do, how can we make this a algorithm that we'd be able to essentially work into our solution here? So what I propose is that we do this. Let's go back to that original example that we had, 1, 2, 3, and 4. We can create our output array. We can just go ahead and just initially set all the values to 1. And the reason for that being because whenever we're going to be doing multiplication, 1 times anything is going to equal whatever that value is. So we can pretty safely assume that, this is a safe value to use at the start here. Then what I propose that we could do is we could have a temp variable here. And we could just go ahead and we can initially set that guy to 1. Then what we could start doing is we could start to fill up our output array with these 0.1s up here. So in other words, those are all the values that are going to be the product of the values to the left of the index that we're looking at. So how could we do that? Well, we could make use of our temp variable here, and then we could just iterate through our original loop, take the values, multiply them together, and then put that in our output array to signify what the values to the left of the array are. So let's go ahead and let's run through what that might look like. So what we would do is we would start at our output array index 0, and we would initially assign that to temp. In this case, temp is 1 whenever we're starting, so nothing changes there. Then we would take temp and we would multiply it by the value at the index of the value that we're looking at in the original array. So in this case, that's this 1. So 1 times 1, in this case, that 1 would get updated, but it would stay a 1. Then what we would do is we would take this 1 and we would update this value, and we would set it equal to 1. Again, we're not changing anything, so nothing changes. Then we would go ahead and grab the value at our original index for index 1, which is a 2, and we would multiply that by temp, which would now set temp equal to 2. And then we would move on to this value in our product array, and we would say, we would just overwrite that value to be our value in temp, which would be 2. And then we would go and look at the corresponding value in our original array, and we would multiply that by temp. So now we would have temp equaling 6. And then we would go ahead and we would look at the value in the last spot here, and that's 1, but we would just set it to be 6 in this case. And so now what we have done is the array on the bottom here, this now signifies the product of the values to the left of the index in the original array. So if you look at the 3 in the original example, the product of the values to the left of it is 1 times 2, which is 2, which is what we have in the corresponding index here. If you look at the 4, the values, or the product of the values to the left of it is 1 times 2 times 3, which in that case also gives you the 6 that we're looking for right there. So now let me go ahead and let me just clean this up here a little bit, clean that, and then just write that back in as our 2. Alright, and then while I'm at it, let me go ahead and get rid of these pointers here, get rid of this here, and then what I propose that we would do is we would take our temp value here, and we would go ahead and we would just set that value back to be 1. Then what we would do is we would work in a reverse fashion here. So now we already, inside of our array here, have the values to the left, which again was this 0.1 here. And now we're going to go ahead and we're going to fill in the part 2 by iterating through the array going from right to left. And then what we can do is we can multiply the values together inside of our output array here, and then that will give us the solution that we're going to be looking for in this type of problem. So let's go ahead and let's work through that. So in order to do this, what we would do is we would take our output array and we would take the value at the index that we're looking at, which again, in this case, we're starting on the right, which is 6. We would take that and we would multiply it by the value that we have in temp, which in this case is 1, so 6 times 1 is 6. We would take that value and we would go ahead and put it back in this index here. So in that case, we replace 6 with 6, and that's taken care of. Then what we would do is we would take our temp value, and we would multiply that by the value at the index of the original array that we're looking at. So in that case, it's 4, so the 1 would just get updated to be a 4. So let's go ahead and do that. Now we would go ahead and we would take our pointer, we would move it 1 spot to the left, and now we would go ahead and take this 2, multiply it by 4, that gives us a value of 8, so we get rid of the 2 there, and we go ahead and put in 8. Then we would look at the value in the original array, which in this case happens to be 3, so we would multiply that 3 times our current temp value of 4, and that would set it equal to 12. And then we would go ahead and we would move on. So now we'd move our pointer over to the second index here, index 1. And so what we would do is we would take 1 times 12, in that case that would just be 12, and we would update that value here. So we go ahead and throw in 12, and then we'd have to update our temp value again by looking at the value in the original array, which in this case is 2. So we would overwrite our temp value, 12 times 2 is 24, and then we would just go ahead and we would take our pointer and we would move it 1 spot to the right, or to the left, sorry, and now we're sitting at the start of the array. The value that we have sitting here is 1. We would multiply that by our temp value. 1 times 24 in this case is 24. And then we would notice that we get to the start of the array, which would signify that this part of the iteration is complete. And so now you can see that we've iterated from left to right and then right to left. We have combined products of the group 1 up here and the group 2 together, and we have our product array, which is the product of the entire array, excluding the value at the index in the original array, which is the solution that we're looking for. So let's go ahead and let's think about time and space complexity. Whenever it comes to time complexity, we originally filled up the array with 1s, and then we iterated from left to right, and then we iterated from right to left. All that was done 1 time, and all those operations are O of n, which would simplify to giving us a time complexity of O of n. Now when it comes to space complexity, we're not using any type of extra memory, we're just generating our array and returning it. So in that case, we have that O of 1 space complexity that we were aiming for at the start of the problem. So with that, I think we have a pretty good algorithm. Let's go ahead and let's jump over to the code. So let's go ahead and let's jump over to the code here. All right, so the first thing that we know we're going to need here is we're going to need a variable to have the length of the array. So let's just go ahead and grab that. And then I'm going to go ahead and I'm going to just grab some extra values here. And I'm also going to grab our temp and I'll just set it to 1 initially. Then I'm going to go ahead and instantiate our product array. So that's just going to be a new int of size n. So now let's go ahead and let's fill that array up with 1s. J++, and then prod j is equal to 1. Okay. So now we're going to work on the part of the algorithm that's going to give us that group 1 that we were talking about earlier. So in order to do that, we'd want to go ahead and create another for loop, and we would iterate through the length of the array. And we would take the product array index I, we'd set that to be temp. Then we would take temp and we would multiply that with our nums array at index I. Then we would go ahead and we would just set temp back to 1 to clear our values. And then we could go ahead and we could just create another for loop here, and this time we would be starting at the end of the array. So we would iterate until we are greater than or equal to 0. We would decrement this time. What happened here? Get rid of that. There we go. And we would set the product at index I. We would multiply that with what our temp value is. Then we would take our temp value and we would multiply that with the nums array at index I. And then whenever all that is finished, we can go ahead and just return our product array. So let's go ahead and let's submit this and let's see how it does. All right, looks like we got a success here. Runtime 1 millisecond. Memory usage 50.6 megabytes. Pretty fun little problem. You can see there some next challenges that we can tackle. If you'd like to see me tackle one of the problems that is listed here, go ahead and let me know in a comment down below. Otherwise, you can take a look at another problem that I've solved on screen now, or you can take a look at my playlist that has all the LeetCode problems that I've tackled up until this point. Until next time, friends, thank you for watching.